why does software break, and how to fix it. Ever excitedly install a new software update, only to find it crashing, freezing, or just plain not working? You're not alone. Software, even the most sophisticated, can be surprisingly fragile. In this video, we'll dive deep into the mysterious world of software breakdowns. We'll explore the common culprits, from user errors to sneaky bugs lurking in the code. And most importantly, we'll discuss how developers can build more robust and reliable software. Believe it or not, a significant portion of software issues stems from us, the users. We humans are prone to mistakes, and these mistakes can have unintended consequences within the software. For example, entering incorrect data, clicking on the wrong button, or accidentally deleting important files can all lead to unexpected behavior, or even system crashes. But user errors aren't the only culprits. Poorly written code can introduce subtle bugs that are hard to detect and even harder to fix. Things like insufficient error handling, lack of documentation, and overly complex logic can create a nightmare for developers and users alike. That's why maintaining high code quality standards is absolutely crucial. Modern software often involves many interconnected parts. When these components don't play nicely together, integration issues arise. Imagine trying to fit a square peg in a round hole. That's essentially what happens when software components don't communicate effectively. This can lead to unexpected behavior, data inconsistencies, and ultimately, system failures. Outdated software is a prime target for hackers. Security vulnerabilities are constantly being discovered, and if your software or its dependencies are not updated regularly, you're leaving yourself wide open to attacks. This is why keeping your systems up to date is crucial for both security and reliability. So, how can we build more reliable software? Thorough testing. Automated testing tools like Playwright and Robot Framework can simulate user interactions and identify potential issues early on. Code quality. Emphasize clean code, proper documentation, and regular code reviews to ensure maintainability and reduce the risk of bugs. Integration testing. Rigorously test how different components of the system interact to prevent unexpected behavior. Continuous improvement. Building reliable software is an ongoing journey. It requires a commitment to continuous improvement, including continuous integration, continuous delivery, CI/CD. Automate the build, test, and deployment process for faster and more reliable releases. Staying updated. Regularly update your software and dependencies to address security vulnerabilities and incorporate the latest improvements. By understanding the common pitfalls and implementing these strategies, we can create software that is not only functional, but also robust and user-friendly. In the ever-evolving world of technology, continuous learning and adaptation are key to building successful and reliable software.